Hey there, everybody. Welcome to our last installment of the trigonometric problems in this Calc prep assignment. This is assignment number 16. Welcome to Math from the Void, where radians and degrees quietly catalog the infinite, and pi circles overhead, watching us, indifferent to our gaze, but ever present in its brilliance. In this episode, I prefaced to prepare with reviewing some identities that you are going to need. We're going to use those identities today, as well as inverse trigonometric operations. Inverse trig operations are how you solve trig equations, which is the last step, the depths of our journey in trigonometry. So let's get right into this. There are going to be a couple of algebraic techniques sprinkled into this assignment, but it's mostly a trig-heavy process. Here we go. If sine of theta is equal to negative 0.2987, and we are allowed to use a calculator just for this first one, for part A. We want to solve for theta, and we need to use the sine inverse rule. That's going to take us from 0 to 2 pi as a limitation on our angles. So let's just draw what this looks like on a unit circle. This looks something like the y value of negative 0.3, which would be somewhere around here, somewhere around there. So our instincts should tell us that it's going to be just before 2 pi, and also just greater than pi. Now our calculator is only going to tell us the angle between negative pi over 2 and pi over 2, as we saw in the previous assignment. So let's figure out what that is. Go ahead and use your calculator for this one problem, since these values are not clearly on the unit circle. We're going to do the sine inverse with negative 0.2987. Again, we're going to want our answer in radians, so we're not going to get any pi involved, but we're going to have our answer in radians. That should give you an angle of negative 0.30333. Wow. And that's what this little angle is here, going backwards. Little tiny wedge. Now the sine inverse rule tells us that if sine of theta is a solution, then theta minus 180, or theta minus pi, is also a solution. Sorry, pi minus theta is also a solution. This is the supplement angle. And so we will take pi and subtract this value, which is pretty much like adding 0.30333 to pi. And this gives us 3.4492. Now, because of our range here, or our interval of restriction, we need to change this angle. We cannot call this negative. We need to make it somewhere between 0 and 2 pi. So we're simply going to add 2 pi. And that will give us our second angle, which is kind of like our first angle, but we're just finding the coterminal angle for this position. And you should get 5.9798. And we'll leave this as 6. So if we think about it in terms of going forward in angle, it's almost a full 2 pi. 2 pi, it would be about 6.28. And this is getting pretty close to there. It's almost 6, so it's pretty close. This angle here is just more than pi, which makes sense because if we use that representation on the unit circle, we have here's pi, and then going a little further leaves us at 3.44492, which is just a bit over pi. All right, I think we're going to be good with these two answers, given the interval. We have to respect the interval. So solving the trig equation is one thing, but putting your answers into the correct interval is another part of the battle. Okay. Cosine x equals negative rad 3 over 2. You should be able to do this in literally about 10 seconds. There are two angles of interest. I'll take my time to draw this so that you can see what I'm talking about. Cosine is the x value on the unit circle. So we're looking at these two angles. That's simply going to be 5 pi over 6. And we can do the thing plus 2 pi k. So anytime I go around the circle one full time from the 5 pi over 6, if I make one full turn from there, I end up at the same location. Or if I make one turn going backwards, which is equivalent to subtracting 2 pi from the angle, I end up in the same location. So these are all solutions. We say k is an integer. Sometimes you'll see it written like this, k, and then a kind of weird e, that means an element of, and then a z. Yeah. Yeah, it's kind of like a forked e, kind of like a, what do they call that? A trident? Almost like a trident, not quite. And the other solution here is going to be 7 pi over 6. So like I said, I took some time to explain that and really go over it, but I want you to know it at the level of, or the speed, really. I want you to know it at the speed of about 10 seconds for both of those solutions. At least identifying where they are on the unit circle. The whole 2 pi k thing, if it takes you a second to think about that and make sure you're checking your interval, then that's fine. But I want you to be familiar with the unit circle such that you can look at an equation like this and say, I know exactly where that happens on the unit circle, like very quickly. You just got to treat it like a, before this whole realm turned into a void and we used to go to stores and markets, you knew where certain things were at if you got them all the time. So familiarize yourself that much. Or at the mall, you might know where the shoe store is at. You might know where the jewelry store is at. You might know where the snack shop is at, or the candy store. You knew exactly where they were at. You could visualize them. That's how you need to be with the unit circle. Let's look at something that's going to require some algebraic technique. Now, if you're really familiar with the unit circle, this will require no algebraic technique, because what this basically says is it says on the unit circle, if we're looking at the unit circle, the y value is equal to the x value, because sine of theta is the y value on the unit circle, and cosine of theta is represented by the x value on the unit circle. So if you know that they have to be the same, there's really only two positions where that could be. They need to either both be positive and be right in the middle, so right here, or both be negative so that they're the same value, like that. If we look at these other 45-degree points, they won't be exactly the same. They'll be negatives of each other. One will be positive while one is negative. We want them to both be the same exact value. So we have that spot, and we have that spot, roughly. So what is that? We call that pi on 4. And, 5 pi on 4. That's it. Very simple, if you know the unit circle very well. If you don't know it quite as well, 1, get better. 2, solve it this way by dividing both sides of this equation by cosine. And if you do that, you get sine over cosine, which is simply tangent. And on the right side, you get cosine over cosine, which is simply 1. And now if we do the tan inverse of 1, when does tangent equal to 1? Well, again, that's going to be this 45-degree angle and this 45-degree angle. So we have the tan inverse rule, which says we're going to do tan inverse. That's going to give us a value somewhere along the first and fourth quadrant, from negative pi over 2 to pi over 2. Remember these ranges of trig inverse functions that we looked at. And then we're also going to have pi plus tan inverse. So our calculator would tell us pi over 4. If we were looking at tan inverse as a function, that's what I mean when I say the calculator would tell us. I'm not suggesting you should use a calculator for these problems. These ones were given with values that are nicely represented on the unit circle. So we have pi over 4 and 5 pi over 4. Okay, now it's time to use some identities. And again, just a sprinkle of algebraic technique. This is a double angle. Did you study your double angle formulas? If not, it's no surprise why you need these videos to be prepared. Because you didn't study. And as much as I can help you here in the void, you're going to have to study, because I cannot be here with you forever. Let's use the replacement of the double angle formula for sine. And move things over. I know it's very tempting and convenient looking that cosine of x is present on both sides. So maybe you want to just simplify the whole equation by dividing cosine. Do not do that. It's possible that at some point cosine is equal to 0. So what you've just done is you've just potentially divided by 0, which I know it doesn't sound as serious as actually trying to divide by 0. But it's just as dangerous, just as risky, because it eliminates possible solutions in our final result. You'll see what I mean in just a moment, so bear with me here. Subtract the cosine of x from both sides, and now we have things equal to 0. We like that because we're able to solve these equations with factoring when they're equal to 0. Not all equations are nicely factorable, but this one happens to be factorable. We can factor cosine x out of the expression and be left with 2 sine of x minus 1. And now we use the zero product property, another algebraic technique. It's a beautiful, beautiful technique that motivates lots of solving equations in further maths. So cos equals 0. And we have to use our unit circle knowledge to quickly determine when this is true. We are given the interval, so make sure you respect the interval of just one loop around the unit circle. Here we'll have x is pi over 2, and therefore we also have, based on the cosine inverse rule, we also have x equals negative pi over 2. But since that's not in the interval, we're going to have to get the coterminal angle by adding 2 pi, and maybe you already knew that that was going to end up at 3 pi over 2. So that's a way of respecting the interval. I'm using the cosine inverse rule because I want to make sure that the rule is repeated here. You do the cosine inverse, and then you take the negative of that angle. But since that negative angle is not in our interval, we have to respect the interval and find a coterminal angle, which is in the same location, but it's within the interval. Okay, now this requires a little more algebra, just simple algebra. And we get that sine of x equals to 1/2. Therefore, our two solutions are going to be x equals pi over 6 and x equals pi minus pi over 6 based on the sine inverse rule. And this is within the interval, so we are respecting the interval. So those 4 solutions work. Oops, maybe I'll use the same color for these. All right. Last, we're going to finish up with this quadratic looking expression. And we're once again going to use a trigonometric identity. Notice in this one that the angles are from 0 to 360, not including 360 this time. So we're going to be in degrees here. Which identity do we have to use now? I see a squared, And I also see a cosine. I can't easily turn a cosine into a sine, but I can pretty easily turn a sine squared into a cosine squared. And that's because we know sine squared plus cosine squared is equal to 1. Therefore, I can replace sine squared with 1 minus cosine squared if I get the sine squared by itself. So let's change this entire equation. Let's call it 2 minus 2 times, instead of sine squared, 1 minus cosine squared equals negative 5 cosine minus 2. And we can work this out, but now you can probably see that it's much more clearly a quadratic. It's a quadratic in cosine. So let's make a substitution for cosine. Let's say u equals cosine. So now we just have 2 minus 2 times 1, 2 times negative u squared so it becomes positive 2u squared, and this is equal to negative 5u minus 2. This equation simplifies quite a bit. If I move everything over to the left side, and now I can solve this. It's possible that this factors. You want to try to factor it? Good idea. Of course, one of these has to be 2u, and one of these has to just be u. And then one of these has to be 2, and one of these has to be 1. Well, if we think about it here, let's multiply the 2 with the 2 and the 1 with the 1. That's going to give us 5 in the middle. So it looks like we're good to go. And this all equals 0. Factoring is a very, very powerful skill. Now if we want to solve each of these, I'll do this up here. We're going to have 2u plus 1 equals 0. And we're going to have u plus 2 equals 0. So that means u equals a negative 1/2 and u equals a negative 2. I want to check something on a previous problem. Okay, I'm making sure that I got positive 1/2 correctly. This one is 2 plus 1, so it turns out to be negative 1/2. Small diversion. Now let's replace things back, because this does not just mean u is equal to negative 1/2. This means cosine is equal to negative 1/2. And this means cosine is equal to negative 2. Now one of these equations should strike you as unacceptable. This is not acceptable, because cosine of x, that does not look like a c. Cosine of x is always between negative 1 and 1, including those endpoints, but never more than that. So absolutely not negative 2. Then we're going to get two angles here, and since we're in degrees, let's take a look at a diagram of the unit circle. Negative 1/2 on the x would be right about there. So what are these two angles? We're going to have 120 degrees, and we're going to have 240 degrees. You made it. You're done with the trigonometric preparation. What I'd like you to do is go back and make sure you can do every single problem that's been covered in this trig prep, so that you know that you're prepared to move forward. And you can also feel proud that we are well over halfway through this assignment. I know the void is intimidating, but you've made it very far. See you next time.